Okay, so this is a rewind on number 103. We started it in class and I messed it up and I realized what I did now. And amazing how looking at the answer key can help you do that. Okay, so this is the position function. It tells like this ball's dropped from 100, or object just dropped from 150 meters and it's fallen. And this is the equation that describes where it is. That's the position. If I want to know the velocity, what I do is I take the limit of the slope of the position function. And so what I had done in class is I had just said t is 3 and I plugged in 3, but what I really need to do is this. If you think about a curve, if something's falling down, maybe it's dropping like this, you've got a point here, like let's say 3, and then you're going to try to find the slope, so you need another point really close to it. So what we're going to do is we're going to take the limit as the time approaches 3, but what we're going to do, we're going to plug 3 in for s of a, and then we're still going to have the t variable in our equation, and that's where I went off and got kind of confused. So s of a, basically we're plugging in, even though they said time is 3, this is our a value, so we're plugging in a is 3. So if you look up here at the limit as the slope, we need to plug in s of 3. We need to plug in 3 into the function. So it's negative 4.9 times 3 squared plus 150. But then we're going to subtract s of t. And what is s of t? It's the whole function there, negative 4.9 t squared plus 150. And on the bottom, we get, if we're plugging in 3 for our a here, it's the number that we're plugging in, it would be 3 minus t. It's a minus t, but remember a is 3 here. So if we simplify this, which is what we're supposed to do, we'd actually done some of this in class and got some of these numbers already. That would be, okay, I stopped a minute to go use my calculator. This number, negative 4.9 times 3 squared, is negative 44.1 plus 150. I could add it all in, but let me show you why I'm not going to. If I get to minus and I distribute it, it's going to be a minus is a plus 4.9 t squared. And then minus 150, this is why I didn't add it together. This plus 150 and this minus 150 would cancel out. And then I have that all over 3 minus t. And I have limit as t approaches 3 of negative 44.1 plus 4.9 t squared all over 3 minus t. Now this is probably going to have to go on to the next page. Now I'm realizing now that what I should have done, sometimes we do things and we go, well, that didn't help me any, I'm going to have to undo it. This negative 44.1, that was way up here. That was that minus 4.9 times 3 squared, which is 9, right? If I leave it that way, I can factor out minus 4.9, and that would leave me 9 and then plus t squared over 3 minus t. Now, if you're looking, okay, all I did was factor out the negative 4.9. Oh, I forgot that when I factored out a negative 4.9 from this term, that would turn this into a minus, okay? If you don't do exactly everything, the next step right, this is not working out right, going to work out right. Okay, so here we go. Now, if I plug in 3, you can see I'm going to have 3 minus 3 on the 0, so there must be something I can do, and there is. This is the limit as t approaches 3, and what I'm going to do is something that if you had multiplied all this out, you wouldn't have even seen to do. Okay, you can factor 9 minus t squared. It's the difference of 2 squared. It's 3 minus t, 3 plus t. Would you get this on a test? Absolutely not. This is kind of difficult to just know what to do next. And then on the bottom I got a 3 minus t. Well, the reason that we factor it that way is because this would cancel out. And what I'm left with, and I'm going to have to go to the next page, is negative 4.9. And then I had a t, let's see, the 3 minus t, so I've got a 3 plus t left. And then it's the limit as t approaches 3. So now I can plug it in, and I'm going to get negative 4.9. 3 plus 3 is 6. So negative 4.9 times 6 is negative 29.4. And since this is velocity and it was in meters and seconds, it would be meters per second. So that was number 103. And there's a lot of little tricky things there that if you didn't see, to not go ahead and combine stuff and leave it where you could factor stuff out, you were kind of didn't have a way to get out of it. They gave you the position function. It was s of t is equal to negative 4.9 t squared plus 150. And they want to know, when is the object going to hit the ground? Well, the position is the height. So when it hits the ground, wouldn't the height be 0? So I could set it equal to 0. That's all I'm going to do here. This is not any limit stuff at all. Okay, so I need to solve for t. What I'm thinking here, since we have a t squared and we got a bunch of numbers, let's get the t's by themselves. And what I'm going to do is I'm going to add the 4.9 t squared to each side so that my t's are positive. Okay, so that gives me 4.9 t squared is equal to 150. And then to get the t's by themselves, first of all, let me divide out the 4.9. I'll just use a different color to show that. So I got a calculator open over here. I'm going to go divide that out. These will cancel out, and I'll have t squared equal, so t squared is equal to 30. I'm going to come out a few digits, 0.61224. Okay, so I'm just going to leave some digits in there. What I would do is leave the whole string in my calculator, and then I would just square root both sides. T equal, when you square root that, you get about 5.5328. We'll just say about 5.5 seconds. So in about 5.5 seconds, it's going to hit the ground. And so that's what you do with 104. Okay, if you're looking at 113, it says true or false. If you take a limit as x approaches 0, it's going to be 1. Well, that's false. And if you had trouble with it, and that's why you're watching this video, think about, like, what if I had negative 0.9, that's coming from the left-hand side. Let's say it's negative 0.999. So it's the limit of 0.999, but it's the absolute value over negative 0.999. Now the absolute value on top would give you a positive 0.999, and on the bottom you'd have a negative 0.999. Well, you know, these could cancel out, but it's still not going to be a positive one. It's going to be a negative one. So as you're coming from the left, if you plugged a negative number in, because of the absolute value sign, the limit would actually be negative 1. So you just got to be careful about little things like that. Okay, so 114, they're trying to trick you a little bit. If you look back at your theorem 1.9, the trig theorems that we had on page 65, the limit as x approaches 0. So here's where they're messing with you. They put a pi here instead of a 0. If it had been a 0, sine x over x would have been 1. So, but that's not what they did. You can actually, the only reason we couldn't plug 0 in is because of this denominator here. If we plug 0 in, we would have had 0. That's why we had to have the special theorem. We could actually evaluate this theorem. Limit as x approaches pi of sine x over x would be sine pi over pi. Well, pi is on our unit circle. It's right here. And this is the point, negative 1, 0. And you remember the cosine is the x coordinate and the sine is the y coordinate. So sine of pi would be this 0 right here. So it's 0 over pi, which is 0. So it's not 1 at all. It's 0. So you got to be careful. We get so excited about seeing a familiar form that we think, oh, it's going to be 1. But you got to be careful. The theorem only applies to when x approaches 0. And I think that's all they're trying to clarify with that problem there.